Our study of circles began with the formal definition of the circle. If you recall, a circle is the locus of coplanar points that are equidistant from a given center. With the definition of circle under our belt, we can dive a bit deeper and examine the special elements of a circle. Firstly, this equal distance from the center we keep talking about has a specific name, called the radius. The plural form of radius is radii. The radius is any line segment with an endpoint on the circle and an endpoint located at the center. The following line segment is unlike a radius since it stretches from one end of the circle to another end. These kind of lines on a circle are called chords. A chord is any line segment with two unique endpoints located on a circle. The following segments shows some of the infinite number of chords a circle can have. The diameter of a circle is a specific kind of chord. The diameter of a circle is any line segment beginning and ending on the circle with its midpoint located at the center. The diameter always consists of two opposite-facing radii, and by definition is always twice as long as a radius. There are two equations that relate the radius with the diameter. The first is r equals 1/2 times d, while the other is d equals 2r, where d represents the length of the diameter and r represents the length of the radius. The radius is proportional to the diameter, which can be seen from these equations. For example, if circle A has a diameter of 4 units, then using our first equation, plugging in our value for d will give us r equals 1/2 times 4. 1/2 times 4 equals 2, and therefore the length of our radius is equal to 2 units of length. If we knew that the radius of circle B was 3 units long, then using our second formula, we would have d equals 2 times 3. 2 times 3 equals 6, and therefore the diameter of circle B has a length of 6 units. So far we have covered some of the line segments that are special to the circle. But what about the curve that makes up the circle itself? The perimeter of the circle, or the distance around the circle, has a special name: circumference. The circumference of a circle has the following formula: c equals 2 times pi times r, where c represents the length of the circumference of the circle, and r represents the length of the radius. There is also a new symbol that may sound familiar to you: pi. Pi is a lowercase Greek letter that is a constant, which is a value that never changes, that is equal to the ratio of the circumference and diameter. This constant is an example of an irrational number, a number which is not equivalent to any fraction of integers. You may have heard people in the past try to recount the value of pi, 3.1415926535, and so on. The decimal places go on forever and never repeat. For the purposes of our study, pi will be equivalent to simply 3.14. Using our equation in an example, if circle C has a radius of 4 units, the circumference would be equal to 2 times pi times 4. 2 times 4 equals 8, and 8 times pi, or 3.14 in our case, equals 25.12. The circumference of our circle is approximately 25.12 units of length. I say approximately since our value of pi is not the actual value, but a rounded value of pi. Our final topic for this lesson is the area of a circle. Much like the length of the circumference, the formula for the area of a circle includes our constant pi. The formula for the area enclosed by a circle is a equals pi times r squared, where again r equals the length of the radius, and pi is a constant equaling 3.14. An explanation of where this formula comes from is outside the scope of this course. Nevertheless, this formula is useful for calculating the space enclosed by a circle. For example, if circle D has a radius of 4 units, then after plugging in our value for r, we get a equals pi times 4 squared. 4 squared equals 16, and pi times 16 equals approximately 50.24 square units of area. In conclusion, we have built upon our knowledge of the circle and studied some of its main properties. In the next lesson, we will discuss how to plot circles on the coordinate plane.